Morning to all, myself K. Nagateja. I am from Mechanical Engineer. Subject Mechanics of Solids. Today topic about shear stress distribution in T-beam section. Next. Introduction about a T section. In a T-beam, the shear stress distribution is not symmetrical because the cross section itself is not symmetrical about the neutral axis. The shear stress is highest at the neutral axis and decrease towards the top and bottom edge of the beam. Next, formula. The calculation of shear stress tau under any point is based on the following formula. Tau equal to V into A into Y bar all divided by I into B, where V equal to the shear force acting on the cross section. A is the area of the cross section above or below the point where the shear stress is be located. Y bar y is the distance of centroid of area A from the neutral axis. I the moment of inertia of entire cross section about the neutral axis. B the width of the cross section at the end point where the shear stress is be calculated. This is main formula for shear stress distribution. Tau equal to V into A y bar all divided by I into B. Step 2, determine shear stress distribution. First one, locate the neutral axis. Neutral axis short name is NA. The first step is to find the centroid of the T section. The neutral axis passes through the centroid. This is done by taking moments of individual rectangular areas, flange and web, about a reference axis. Example, the bottom edge. Second one is calculate the moment of inertia. Moment of inertia is represented by I. Determine the moment of inertia of entire T section about the neutral axis using parallel axis theorem. Next one is third one. Calculate shear stress in the flange. At the top edge, the shear stress is 0 because the area A above this point is 0. At the junction of flange and web, the width of B change abruptly here. Therefore, there will be two values for the shear stress. At this level, one for width of the flange and one for width of the web. Calculate the shear stress using flange width. Calculate the shear stress again using web width. This will result in a sudden sharp increase in a shear stress value. Next one is calculate shear stress in the web. Within the web, the shear stress distribution follows a parabolic curve at the neutral axis. This is where is the maximum shear stress occur. You will need to calculate the value using the area above the neutral axis. Fifth calculation is calculate shear stress at the bottom edge of the web. The shear stress at bottom edge is 0 as the area below this point is 0. Visualization shear stress distribution main visualization of diagram. The diagram is a symmetrical mirroring and the asymmetrical T section itself. The shear stress is 0 at the top and bottom surface. The next one is the shear stress increase parabolically for the top edge to the neutral axis. Fourth one, there is sharp increase in the shear stress at the flange web junction. Fifth one is the maximum shear stress is at the neutral axis. Final, the shear stress decreases parabolically from the neutral axis to the bottom edges. This is main visualization of any diagrams of shear stress diagrams. The one of example problem for shear stress distribution for T section. The example one problem for shear stress distribution for T section. Next one. One is problem for example. A T-shaped cross section of a beam has a top flange of 200 into 50 mm and web 200 by 50 mm. It is subjected to vertically shear force of 120 kN. Find the shear stress at the neutral axis MOI. MOI means it is a moment of inertia of the section about the horizontally neutral axis is 1.134 into 10 meters square. This is T section. The T section figure shows two flange and web. Flange, upper flange, web. Example for I section, there are three upper flange, lower flange, web. This is example for T section. Only upper flange, web. Next one is shear stress distribution in the flange. First, you know the shear stress distribution in flange. The shear stress at the top edge of flange and bottom of the web is zero. Shear stress in the flange just at the junction of flange and web is given by tau equal to V into A y bar by I into B, where A equal to 200 into 50. A means area of rectangle. 10,000 mm square. Y bar distance of CZ of area of flange from NA means neutral axis. From neutral axis 87.5 minus 50 by 2 equal to 62.5 mm. B width of the flange equal to 200 mm. Tau is equal to V 120 into 10 cube into A 10,000 mm square into Y bar 62.mm by I moment of inertia 113.4 into 10 power 6 B into 200 equal to 3.31 Newton per mm square. Hence neutral axis will be at a distance of 87.55 mm from the top of flange as shown in figure. Next figure. Hence, neutral axis will be at a distance of 87.5 mm from the top of flange as shown in figure. This is for upper flange and web. This diagram explain about finally skip. Shear stress distribution in the web. The shear stress in the web just at the junction of the web and flange will suddenly increase from 3.31 Newton mm square to 3.31 into 200 by 50. That is 13.24 Newton per mm square. This shear stress will be maximum of neutral axis. Hence, shear stress at the neutral axis is given by tau is equal to same formula. Shear stress distribution. Tau is equal to V into A into Y bar by whole divided by I into B. A means area, I is equal to moment of inertia. B means bed. Where A y bar equal to moment of inertia, the area above neutral axis, about neutral axis, above neutral axis, about a neutral axis equal to moment of area of flange about neutral axis plus moment of area of web about neutral axis 200 into 50 87.5 minus 25 plus 50 into 87.5 minus 25 in bracket 87.5 minus 25 divided by 2 is equal to is whole equal to 722,656.25 mm cube. B is equal to 50 mm width. Tau max equal to 120 into 10 cube into 722,656.25 by 113.4 into 10 power 6 into 50 equal to 15.26 Newton per mm square. This is final answer. Now the shear stress distribution diagram can be drawn as shown in figure below. Diagram T6 shear stress distribution final diagram. This is flange, upper flange, web. Upper flange shear stress distribution is 3.31. This is now 3.31 final answer. Newton per mm square. 3.31 Newton per mm square. This is upper plane 3.31 shear stress distribution. Next 15.29 is this is 15.29 Newton per mm square. This is final answer. Web. This is curve is parabolic curve. The center of the neutral axis. Thank you from this section. Mechanics of solids. Thank you.